Hello, today I'll be going over the fundamentals of facial and object detection. Here is a general overview as to what I will be talking about in this video. There are timestamps in the description if you're interested in one thing but not the others. In this video, I'll be demonstrating a basic Python script that detects and highlights a face using images from a live camera feed. Then I will break down the code to see how everything is tied together and go a bit more in depth about how the computer processes images in order to detect patterns. I will then briefly go over artificial intelligence and machine learning, which will then lead into the difference between object detection and recognition. Finally, I'll be reviewing how this type of technology can be applied in the real world and how everything relates back to my ISU book, Physics of the Future by Michio Kaku. Here you can see a live feed of my laptop's internal webcam. This particular program is optimized for frontal detection at the moment and draws a rectangle around my face and nothing else. For example, if I were to hold up a picture of someone else's face, let's say Michio Kaku himself for one, you can see that it would also detect it and put a rectangle over it. Now let's get a quick overview of the code and how everything works together to make this happen. This is all the code you need to make the magic happen, half of which are comments to describe what's going on in each chunk of the program. So let's break it down. Here, we're importing the libraries and materials we need to run the program. OpenCV, which is short for Open Source Computer Vision, is an open-source library of programming functions mainly aimed at real-time computer vision and image processing. It's basically a set of filters and operations that can be applied to 2D images. Since videos are made up of still 2D images, this is definitely applicable to what we'll be doing. Here, hard cascade frontal face _all.xml is the file that contains trained classifiers for detecting objects of a particular type, such as different face profiles, pedestrians, and signs. In this case, the algorithm that I'll be using is for the front profile of the face. The rest is just declaring variables so that we can use them for later. Here is a while loop that will run for as long as the program doesn't end. Every time it loops through, it captures a still image frame from the live video, and it filters the image so that the computer is able to work with its grayscale values. Then using the pre-trained model found in the XML file, it detects faces within the still image. Once the computer detects all the faces within the frame, it draws a bright green rectangle around the perimeter and pastes the rectangle onto the output video window. You'd be able to exit the program by pressing the Q key, which will break the loop and then move on to the last two lines, where it then releases the final capture before closing the window. Here is another demonstration to refresh your memory. As you can see here, there is a bright green rectangle just on my face, in the forefrontal part, not on my hands, not on the side profile here, just my front face, because it actually tells what values and what's going on with it. Again, it will still work with Michio Kaku's face and any other images or faces that might come up. Now for how it works. As you can see here in this diagram, there are different filters cast over the original image. These images are examples of what the computer sees when processing said image. It then splits up the image into smaller sections and calculates the brightness gradients within it, which then indicates to the computer which parts of the image get darker or lighter. With this information, it then detects patterns within it. For example, you can generally tell that the eye regions are darker than the nose and cheek regions. So then the computer goes, hey, these things look like eyes. If I'm looking for a face and I already have eye-looking things, then logically and according to the pattern recognition model, this is where the mouth should be. Once it has verified that every component of the face is there, it can conclude that there is indeed a face and highlight it for me. Now I will be going over the definitions of artificial intelligence and machine learning, and how it plays into facial detection itself. Artificial intelligence, by definition, is the concept of creating machines that can mimic human thinking, decision-making, and behavior. Machine learning is a subset of artificial intelligence in which machines are able to learn and make decisions according to large amounts of data rather than being explicitly programmed. Typically, the machine is given a set of given input data and the correct corresponding output data. By analyzing the information given, the machine can perform and form connections and detect patterns and make accurate predictions. This is how those models and algorithms can be trained to detect specific objects such as faces, cars, and signs. Notice how I've been saying facial detection all this time and not facial recognition? Although these two terms are used pretty interchangeably, they are very different. Object detection is asking where is this specific object within the image. It is inputted a clear image of the desired object along with another image that can possibly contain that object of interest. Then the program outputs a position or bounding box of the input object if it exists within the image. Recognition ties it to something more substantial, identifying the object present in images and videos. With object recognition, it's asking which object is depicted in this image. In this case, the input is an image containing unknown objects, where then the output is the position and the labels or names of the objects within it. There are countless real-life applications of object recognition. Some of the most popular usages include autonomous transportation, medical image processing, and surveillance and security. Object recognition within autonomous transportation gives cars the ability to detect and identify road signs, other vehicles, pedestrians, and countless other road obstacles and tools in order to ensure the safest route and drive possible. This type of technology is already widely available within modern vehicles in the form of adaptive cruise control and lane centering steering down to a stop. When it comes to medical image processing, object recognition and image processing techniques can help detect disease more accurately. For example, Google AI has been used to detect breast cancer in patients and has in fact detected cancer more accurately than doctors. Machines are infinitely better at detecting patterns than humans are, which is why implementing object and pattern recognition would be such a boon in the surveillance and security industry. They can be used for facial recognition, object tracking, and activity recognition for banking and home security related purposes and companies. Lastly, throughout Physics of the Future, the author Michio Kaku repeats the impossibility of creating a fully autonomous robot. It is impossible to replicate the human mind, which is why it's so fascinating to learn about how machines can do and learn all these things, but never gain the ability to truly think for themselves without complex algorithms telling them what to do with the information they take in. In the end, this facial recognition program only acts as a crude, watered-down version of what really goes on behind the scenes of big tech solutions and companies. This project in its entirety, however, acts to expand on the fascinating ideas addressed in chapters that focused on the future of computers and AI. Those passing ideas really inspired me to learn more and ultimately share my knowledge with others. To learn more about these new technologies, make sure to check out the Vincent Massey Computer Science Club blog for more student-written articles on topics such as autonomous transportation, artificial intelligence and machine learning, as well as virtual reality and augmented reality. If you want to run the face detection program yourself, please check out my GitHub, which is also linked in the description below. Smash that subscribe button and ring that little bell for more notifications. Make sure to like too.